वेलकम टू ग्यास क्लासेस फॉर मैथमेटिक्स। आज हम लोग क्लास 12 थ्री डायमेंशन पार्ट नंबर 10 में एक्सरसाइज 11.3 की इंपॉर्टेंट क्वेश्चन करेंगे। लेट अस सी द क्वेश्चन। सो दिस इज क्लास 12 थ्री डायमेंशन पार्ट 10 एनसीईआरटी बुक एक्सरसाइज 11.3। बिल्कुल बेसिक एंड ट्रिकी क्वेश्चन के साथ इस क्वेश्चन को सॉल्व करेंगे। तो चलो देखते हैं क्वेश्चन नंबर 1। फर्स्ट क्वेश्चन क्या है हमारा? फाइंड द डायरेक्शन कोसाइन ऑफ नॉर्मल टू द प्लेन एंड द डिस्टेंस फ्रॉम the this line. Find the direction cosine of normal to plane and distance from the origin. Yani distance from this point you have to find. So direction cosine of normal to plane and distance from origin we have to find. So for this type of question, what is the rule? See, so answer first. So answer first is what? Given equation of plane is what? X plus y plus z equal to 1, right? और हमें क्या फाइंड करना है? डायरेक्शन कोसाइन ऑफ नॉर्मल टू प्लेन एंड डिस्टेंस फ्रॉम द ओरिजिन। तो फॉर दिस टाइप ऑफ क्वेश्चन फर्स्ट रूल इज व्हाट? कि जस्ट डिवाइड बोथ साइड बाय a square root of coefficient of x square, coefficient of y square and coefficient of z square. That means dividing both side by a square root of coefficient of x1, so 1 square, coefficient of y1 again, so 1 square, and coefficient of z also 1, so 1 square. That means this equal to root under 3. So divide this equation both side by root 3. We will get 1 by root 3x plus 1 by root 3y plus 1 by root 3z. This equal to 1 upon root 3. Now this equation in the form of Lx plus my plus nz equal to d. So Lmn is what? Direction cosine. So here we have to find direction cosine. So direction cosine, that is DCS, is what? 1 by root 3, 1 by root 3 and 1 by root 3. So direction cosine of this equation is 1 by root 3, 1 by root 3 and 1 by root 3. And second we have to find distance from the origin. So distance equal to what? That is this. So this is what? 1 by root 3. So our correct answer is direction cosine 1 by root 3, 1 by root 3, 1 by root 3 and distance from origin is 1 by root 3. So this is the standard equation and basic format for this type of question. Any question is given in the form of x plus y plus z equal to 1. Then you have to change this number first by dividing both sides by coefficient of x square plus coefficient of y square plus coefficient of z square. That is here coefficient of x1, coefficient of y1, coefficient of z1. So divide by root 3 both sides. Then you will get this equation. This form is Lx plus my plus nz equal to d. So comparing we get Lmn, that is direction cosine of line 1 by root 3, 1 by root 3, 1 by root 3 and distance is what? 1 by root 3. Okay, good. Now see the second question. Now second question is answer 2. What is the second question? Find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector 3i plus 5j minus 6j. So this is the question. Find the vector equation of plane which is at a distance of 7 units from the origin and normal to the vector this. So for this type of question, what is the format? See, so we have to find vector equation of plane. So here distance is given is at a distance of 7 units from origin and here given normal to the vector. So what is the formula? That is r dot unit vector n equal to d. So this is r vector dot. So what is unit vector? So this vector is normal to the plane given. So just divide this you can say equation of vector by squaring of coefficient of unit vector I, coefficient of unit vector j, and your coefficient of unit vector k. So this is 3 unit vector I plus 5 unit vector j minus 6 unit vector k, and this divided by a square root of coefficient of unit vector I is 3, so 3 square. Coefficient of unit vector j is 5, so this is 5 square, plus coefficient of unit vector k is what? Minus, so minus k square. And this equal to what? The distance is given how much? 7. So this is the required equation. R dot unit vector, so here vector given, so just change this vector dividing by coefficient of unit vector I square, unit vector j square, and unit vector k square. So we can write this like R vector dot, this is 3 unit vector I plus 5 unit vector j minus 6 unit vector k, divided by, this is 6 square 36, 5 square 25, and 3 square 9. So this is 9 and this is 36. So 9 and 36 is how much? So 9 and 36. So 45, here 5 square 25. So this is 70. So this is a square root of 70. And this equal to what? 7. So this is the required equation. So my question was, find the vector equation of plane which is at a distance of 7 units from the origin and normal to this vector. For this type of question, this is a formula R vector dot unit vector n equal to d. So this is R vector, here vector given. So find the unit vector. So rule is what? Divide the vector by a square root of coefficient of unit vector I, unit vector j, and unit vector k. So this is divided by 3 square, 5 square, minus square. This is root under 70. This is the correct answer. Okay, understood? Good. Now see the third question. So this is the third question, is also most important question. So third question is what? Find the Cartesian equation of plane when r dot 2i plus 3j minus 4k equal to 1. So equation of plane is given in the vector form. You have to find the equation of plane in Cartesian form. So what is the rule? See, at first you see what is given. R vector dot 2 unit vector I plus 3 unit vector j minus 4 unit vector k, and this equal to what? 1. Now we need Cartesian equation of plane. So simple rule is what? This is x, this is y, this is z. So this is correct answer is 2x plus 3y minus 4z. This equal to 1. This is the required equation of plane in the Cartesian form. So find the Cartesian equation of plane r dot 2i plus 3j minus 4k equal to 1. Then you can find directly 2i plus 3j minus 4z equal to 1. This is the required equation. So this is a model question. Any question given in the plane r dot vector equal to 1, and you have to find Cartesian equation. Then just use the formula coefficient of unit vector ix plus coefficient of unit vector jy minus plus coefficient of unit vector k. So here you coefficient 2, 3 minus 4. So 2x plus 3y minus 4z equal to 1. This is the required equation. Now see the question number 4th. So now what is the question 4? See. So question 4 is, find the coordinates of the foot of perpendicular drawn from the origin. Find the coordinates of foot of the perpendicular drawn from the origin. So this is also a model question. Here equation given, coordinates of foot of perpendicular drawn from origin to this equation is given, and we have to find coordinates of foot of perpendicular. So you see how can we solve this question very easily. 2x plus 3y plus 4z minus 12 equal to 0. So you can write this equation 2x plus 3y plus 4z equal to 12. Now divide both sides by again a square root of coefficient of x square plus coefficient of y square plus coefficient of z square. So this is dividing both sides by a square root of 2a square plus 3a square plus 4a square. So this is how much? 4a square 16 and 2a square 4. So this is 16 plus 4 20 and this is 9 29. So this is what? A square root of 29. So this is 2 upon root under 29x plus 3 upon root under 29y plus 4 upon root under 29z, and this equal to what? 12 upon root under 29. Now this is in the form of Lx plus My plus Nz equal to D. We have to find direction, we have to find coordinates of foot of perpendicular. So coordinates of foot of perpendicular is given by what? This is L into D. Okay. So coordinates of foot of perpendicular will be what? 2 upon root under 29 multiply 12 upon root under 29. Again 3 upon root under 29 multiply 12 upon root under 29. Again this is 4 upon root under 29 multiply 12 upon root 29. This give 12 2s are 24 upon 29. This is 12 3s are 36 upon 29. This is 48 upon root 29. This is the required equation. Find the vector. This is find the coordinates of foot of perpendicular drawn from the origin. So this is the required coordinates of the foot of the perpendicular. So again you see equation is given 2x plus 3y plus 4z minus 12 equal to 0. So change this equation in the form of Lx plus My plus Nz equal to D. How can we change? Divide both sides by square root of coefficient of x square, coefficient of y square, coefficient of z square. So here 2a square plus 3a square plus 4a square give 29. So root 28. So divide both sides by root 29. You will get 2 by root 29x, 3 by root 29y, 4 by root 29z equal to 12 by root 29. Now this is LD. So this is 2 by root 29 into 12 by 29. Again 3 by root 29 multiply D root 12 by root 29. Again this is 4 by root 29 into 12 by root 29. This will give you the final result 24 by 29, 36 by 29 and 48 by 29. This is the required equations. So this is what? That is coordinate of the foot of perpendicular drawn from the origin. Okay, understood? Very good. Now you see the next question, question number 5. So this is the question number 5. So what is the 5 question? Find the vector and Cartesian equation of plane that passes through the point 1 0 minus 2 and the normal to the plane is I plus j minus k. That means we have to find vector equation and Cartesian equation of the plane. For this type of equation, what is the formula? So first to find vector equation. So this is vector equation. Vector equation of plane is what? So this is the format is what? R vector minus A vector and dot N vector, right? R vector minus A vector dot N vector equal to what? 0. So here this is R vector minus A vector is what? So here point is given 1 0 minus 2. So A vector will be coordinate, x coordinate is 1, y coordinate 0 and z coordinate minus 2. So here I, j, k. So coefficient of j is here 0. So we have only this is unit vector I minus 2 unit vector k. This is called A point, A vector. So A vector is what? Position vector of this point, that is the unit vector I minus 2 into unit vector k. And dot this is N vector. N vector is given what? Unit vector I plus unit vector j minus unit vector k, and this equal to 0. This is the required equation in the vector form. So find the vector and cut. So we have to find vector equation of the plane that passes through the point and normal to the plane is what? R vector minus A vector dot n vector equal to 0. So this is R vector minus A vector is given position vector of the point. So position point is what? 1, 0, minus 2. So coefficient of j is here 0. So my A vector will be what? Unit vector I minus 2 unit vector k dot. N vector is what? I plus j minus k. Now we have to find Cartesian equation. So for Cartesian equation, put R vector equal to what? That is x unit vector I plus y unit vector j and minus z unit vector k minus I unit vector minus 2k unit vector, and this is dot with unit vector I plus unit vector j minus unit vector k. This is equal to 0. Now you know if this is minus, so what can we write here? So here this is x unit vector I minus unit vector I. So we can write x minus 1 unit vector I. In the same way here y unit vector j, here y not 0. So only we can write y unit vector j. Here minus zk and here minus minus plus 2 unit vector k. So here what we can write? So we can write here, so if we take k common, then you can write plus k into minus z plus 2. Okay, so this is minus zk and here plus 2k. So k is common, so this is minus z plus 2. So this is what? This is unit vector k, right? So x minus 1 unit vector I, y unit vector j, and you can write here minus z plus 2 unit vector k. And now dot with unit vector I plus unit vector j minus unit vector k. This is equal to what? 0. Now you know when we go for the dot product, in dot product we know I dot I1, j dot j1 and k dot k1, and when I dot with j or k it will become 0. So x minus 1 I dot I is what? Only x minus 1. So we can write x minus 1. Again this is y unit vector j and here only j. So y unit vector j into dot j unit vector is what? Only y. So this is plus y. Again this is minus z plus 2k and dot minus k. So this is what? Minus plus minus of z plus 2 into what? Minus 1. This is equal to 0. Now we can simplify this equation. X minus 1 plus y minus plus. So this is plus z and minus 2 0. So this is how much? X plus y plus z. Minus 1 minus 2 minus 3. So this is equal to 3. This is the required equation in the Cartesian form. X plus y plus z equal to 3. So this is the equation in the vector form. For Cartesian form, put r vector equal to x unit vector I, y unit vector j and minus z unit vector k. And minus, it is already given, unit vector I minus 2 k and dot this. So if we subtract this number, so here unit vector I, here unit vector I, so x minus 1 unit I. Here y unit vector j, here y not. So only we write y unit vector z. Again minus z unit vector k, and here what? That is minus 2k. So minus minus plus 2. So when we take k common, so minus z plus 2 unit vector k, and then dot given I plus j minus k. Now we will go for the dot product. In dot product we know I dot I1, j dot j1 and k dot k1. So here's x minus 1 I dot I is give x minus 1. In the same way yj to y unit vector j dot only j give only y. Here minus z plus 2 unit vector k dot k vector. So k minus k vector. So we get minus z plus 2 into minus 1. When we simplify this equation, x minus 1 plus y, here minus 1 into minus z plus z, minus 1 plus 2 minus 2. So we get x plus y plus z equal to 3. In this way, we have solved all the 5 questions, and all these questions are NCERT book exercise 11.3. In the next video, part number 11, we will do more question of this exercise. Okay, so अगर अभी तक आपने हमारे YouTube चैनल ग्यास क्लासेस फॉर मैथमेटिक्स को सब्सक्राइब नहीं किया है तो आप इसे सब्सक्राइब कर ले। यहाँ पे आपको क्लास 11th और क्लास 12th की सारी वीडियोस मिलेगी, एनसीईआरटी बुक एंड अदर बुक्स के भी। ओके, थैंक यू।